Let's take a look at section 5.2, which is dividing polynomials. So the first way we're going to look at dividing polynomials is just dividing by a monomial. And simply we're going to use our quotient rule for exponents. So as you can see in example 1, we have a polynomial, a trinomial, divided by a monomial. And what we do there is we just divide every single term by that monomial. So I'm going to do example 2 with you, and I'll ask you to go back to try example 1. Example 2 is the same type of deal. We're going to take this polynomial, which has 4 terms, and we're going to divide it by our monomial. Now notice in example 2, we have this sort of fancy notation, right? It doesn't actually say divided by. It says multiply it by 4x to the negative 1. But remember, 4x to the negative 1 really is the same as dividing by 4x to the first, because that means to put it as 1 over. So we're taking our polynomial and multiplying it by 1 over 4x, or aka dividing by 4x. So when you see this notation of multiplication by a monomial or a polynomial with the power of negative 1, it really means divide. So what I'm going to do is I'll first just rewrite that so you have that in your notes. Okay, so it's just saying divide that by 4x. So what I'm going to do is literally divide every single term by 4x. And I'll use the quotient rule to get my different results. So 12 divided by 4 is 3. X cubed divided by x, we subtract those exponents, so that gives me x squared. Then we have 8 divided by 4 is 2. Again, subtract the exponents. A 2 and a 1 just makes to the first power. Then we can't divide the coefficients, but I have x divided by x, which cancels, so I'm left with 1/4. And then last but not least, our 4's will cancel, but we are left with an x in the denominator. So there is my result. Okay? Again, you go back to try number 1. Now we're going to look at dividing polynomials by polynomials. And we have 2 methods. We have long division and synthetic division. So let's first review our long division. Long division in general, remember, in this example, without any polynomials, we're dividing 4,086 by 3. So the first thing we say is, how many times does 3 go into 4? Or 4 divided by 3 gives me once. So I put our 1 up here. Apologize, that came out a little funky looking. And then we multiply. 1 times 3 is 3. And then we subtract. So I bring that down as a 1 and carry the 0 down as 10. And I continue that pattern. 3 goes into 10 3 times. The result is 9. Subtract, I get 1. Bring down the 8. 3 goes into 8 6 times. 6 times 3 is 18. And then I bring down the 6. 3 goes into 6 twice. And the good news here is that when I subtract that, I apologize, I'm running out of room, I get a 0. So that went in evenly. I got 1,362. No remainder. We're going to use this same process with polynomials. Okay? However, when we are dividing by polynomials, this is super important where I have the stars. We need to fill in any gaps if there are missing degrees. So if it goes from x to the 4th to x squared, you need to fill in a gap of 0x to the 3rd. And you'll see an example with that. So let's do number 3. If I take a look at the first polynomial here, there are no gaps. It goes x squared, x to the 1st, constant. And then we're dividing by a binomial, which is x to the 1st and a constant. So I'm going to take the x plus 3 out front, because that's what I am dividing by. And I'm going to put x squared plus 5x plus 8 inside. So now we're going to divide. And we just look at the first terms for each. So I say, how many times can x go into x squared? Or x squared divided by x is what? Right? So x squared divided by x, that just gives me x to the first. So I get an x. Just like up above, I said, how many times does 3 go into 4? 1. Now I multiplied 1 times 3. So I'm going to multiply x times x plus 3. This gives me x squared plus 3x. Now we subtract. So remember, because I'm going to subtract, our signs are going to change. So we're going to subtract that entire quantity, okay? So when I do that, we have x squared minus x will cancel, and 5x minus 3x gives me 2x. Now I start the dividing process again. However, I have a binomial outside and just a monomial. So I need to remember to bring down the plus 8. And now I divide. How many times does x go into 2x? AKA 2x divided by x is 2. And it's a positive 2, so I have plus 2. So now 2 times x is 2x. 2 times 3 is positive 6. Now I subtract. So subtract that whole quantity, and our 2x's will cancel, and I'll have 8 minus 6, which is 2. Is there anything else to bring down? No. So this is my remainder. However, we're not going to write remainder 2. The way we write this is we take everything that I got, and now it's a positive remainder, so then plus 2 over that divisor of x plus 3. And there is my solution. Okay? So if there is a remainder, we write that remainder over the divisor. I'm going to do one more with you, and then I'll ask you to try the others. So I'm going to do number 5 with you, and then you complete 4 and 6. So let's look at 5. In this case here, our divisor is x minus 2, so I'll take that out front. But inside here, for the dividend, we have some gaps. It comes from x to the 4th and jumps to 9x squared, so we need to put in a 0x to the 3rd. Now we have our 9x squared, but I don't have an x term, so I need to fill in that gap with a 0x. The reason that's important is because you need to make sure like terms line up on top of each other when we're combining. And so if we don't fill those gaps, you won't have like terms on top of each other. Now we begin the process. How many times does x go into x to the 4th? It goes in x to the 3rd times. Now I multiply. X to the 3rd times x is x to the 4th. X to the 3rd minus 2 is negative 2x to the 3rd. Now I subtract. And what does that give me? That's going to give me my x to the 4th will cancel, and this will be saying 0x to the 3rd minus negative, which really becomes positive 2x to the 3rd. That's a monomial, and I have a binomial outside, so I need to bring down one more term. And I start the process again. X goes into 2x to the 3rd, 2x squared times. 2x squared times x is 2x to the 3rd. 2x squared times negative 2 is negative 4x squared. And now we subtract. Our 2x to the 3rds will cancel. This is negative 9 plus 4x, which would be negative 5x to the 3rd. X squared, sorry. And then we bring down our 0x. And that's okay that it's a 0x. There's still 2 terms there. So how many times does x go into negative 5x squared? It goes in negative 5x times. And I multiply. Negative 5 times x is negative 5x squared plus 10x, right? Negative times a negative. And now we subtract. When I subtract that, we have negative 5 minus negative 5, so that becomes 0x squared. 0x minus 10x, which will give me negative 10x. And I bring down my last term of negative 5. Now I ask myself, how many times does x go into negative 10x? And that's negative 10 times. Multiply negative 10x minus negative 20, so plus 20. Negative 10 times negative 2. And then our last step will be to subtract that. When I subtract that, our 10s cancel, but I now get negative 25. So that is my remainder. So what will I do? I will do minus 25 all over x minus 2. And there is my solution. Okay, so please use long division to try 4 and 6. Do not forget about the gaps. And remember on 6, this is just a fancy way of saying divide. Okay, don't forget the gaps on both 4 and 6. Okay, now let's look at synthetic division. So for synthetic division, we can only use this when we're dividing by a binomial with a power of 1. Okay, so only can be used if dividing by binomial of degree 1. Okay, so a lot of people like this way because it's much more efficient. However, it can't always be used, so that's why we need to know long division. So let's look at how this works. For synthetic division, we're just going to use coefficients and constants. So what I first start off with is I find the opposite term of what I'm either adding or subtracting. So it's a negative 2, so I'm going to take a positive 2 out front. Now what goes next to it are all the coefficients and constants of what I'm dividing into. Don't forget gaps again. So my first coefficient is a 4, but that was for an x to the third term. I don't see an x squared term, so I need to fill in a 0. Now I have x to the first term, that coefficient is a 1, and then I have my constant of 7. So notice, all of the variables are gone. I'm using the constants and coefficients. Okay, now leave some space and draw a line. The first step we're going to do is to carry down the first term, which is 4. And now we multiply. 2 times 4 is 8. Add gives me 8. Continue that pattern. 2 times 8 is 16. Add, that gives me 17. Keep on multiplying. 2 times 17 is 34. Add those together and gives me 41. I have done all my computations, but now I need to know what is the answer. So remember, we started with polynomials with the variable x, so my answer better have x's in it. This last column is the remainder column. And then we work backwards. So if this is my remainder column, then this is my constant. This will be x to the first. This would be x squared. And if there was more, we'd keep on going. So that's telling me my solution is 4x squared plus 8x plus 17 plus a remainder of 41. Remember that remainder always goes over my divisor. And there's your solution. Okay? You tried number 8. Don't forget those gaps. All right, and the last one I'm going to do is another synthetic division problem, but the difference this time around is that we have a coefficient in that binomial that we're dividing by. So we're going to start this the same way. We're going to take the opposite term of that negative 1, so we're going to have a positive 1 out front, and then we're going to list all those coefficients and constants. So we have 4. There's no x to the third term, so we have a 0. Our x squared term is negative 5. X to the first is 2, and then my constant is 3. Leave some space and draw a line. First step, like before, is to bring down that first term. However, here is where we have our change. Now what we need to do is, because there's that coefficient of 2 in my divisor, I need to divide this column by 2. So when I do that, what do I now get as an answer? 4 divided by 2 is 2. And now I continue the process like before. I'm going to multiply, but I'm going to multiply 1 times 2, which is 2. Add those together, it's 2, but don't forget to divide now. 2 divided by 2 is 1. We keep that going. 1 times 1 is 1. Put those together, it's negative 4. Divided by 2 is negative 2. Continue. 1 times negative 2 is negative 2. Put those together, that's 0. 0 divided by 2 is 0. 1 times 0 is 0. We get 3, and then we're going to stop. We are not going to divide. Does anyone know why? And you may be thinking, yes, I know why. And hopefully it's because this is our remainder column, right? And when we write our remainder, we already write it as a fraction, 3 over the 2x minus 1. So we're already going to acknowledge the division when I write it as a fraction. So you don't want to divide now because then you'll be dividing twice. So now if that's my remainder column, this would be my constant. This would be, we're dealing with x's, so x to the first, x squared, and x to the third. So my answer is 2x to the third plus x squared minus 2x, no constant, but plus the remainder of 3 over 2x minus 1. And there's your answer. Okay, so now you tried number 10, knowing that we have a coefficient of 3, use those same rules.